we're going to be pointing a small section of a brick wall. I'm going to explain what pointing is, why we do it, how we do it, what tools are needed, what tools are nice to have. I'm going to show you in detail exactly what we're looking for and the thought process behind it all, how to fix it. We even might break the law for a minute. This is the area of the wall that we're going to be pointing today. All pointing is removing old mortar and replacing with fresh mortar. It could be as simple as that. We're going to take a very close look at exactly why we have to do it in this area. There's usually an underlying condition that we might have to figure out before we continue with the repair process, or else we're just going to have to point this again at a later date. We're going to take a close look at exactly what's going on, and we're going to start figuring out what material we might need to repair this. Through experience, I can pretty much tell instantly what's going on with this wall. Here we have a lot of deteriorated mortar. As we work our way over this way, we have a cracked joint. I can remove it with my hand. How much more can we remove? We keep going, removing more just with our hand. What's going on here? This is water damage. Well, how is water getting into this part of the wall? It all starts from these caps. This wall was built very well. It wasn't designed that great. These caps have about 1 inch of overhang, and that's good. In theory, water is going to come down the face of the cap and drip away from the wall, only that's not what happens. The water comes down, gets to this corner, then starts making its way back to the brickwork. And that's where it gets bad. I can see underneath this cap has been caulked previously. It's most likely a crack underneath there. That means water's getting in there, getting in that crack, going into these brick. These are cored brick, meaning there's holes in these brick. The water goes into the cores, gets down into the bed joints, and freezes and thaws and cracks, and it starts deteriorating the mortar, just like this. This could have been alleviated if these caps had what's called a drip edge underneath of them. That's a groove in the stone, in the cast stone, where when water starts making its way back to the wall, it only gets to a certain point and stops and drips in front of the wall, drips down, doesn't make its way back to the bed joint underneath the cast stone. Well, there's about 400 feet of cast stone on this project. We have to make the decision. Do we want to pick up all of these cast stone, relay them, perhaps grind a drip edge into the cast stone, all of the cast stone on both sides, to alleviate this from happening again? That's pretty costly. Or can we make small repairs and buy more time with this wall? That's what the customer is going for here. We're going to be making small repairs, grinding out the deteriorated mortar and putting in fresh mortar. Let's take a closer look at these head joints and bed joints. You saw me remove that first chunk of mortar just with my hand. Here's another chunk. As I remove this, I can tell that this wall, this area, has been pointed before. This mortar is not the original mortar. It doesn't even match in color to the original mortar. The repair that I'm going to be doing is at least the second repair on this wall. We're going to try and do a better job than this. We're going to match the mortar color a little better, and we're going to go a little deeper with our grinding. Now we're taking an even closer look at these mortar joints. Let's look at the joint profile. This is not a common joint profile. It's not a common joint shape. Usually, brickwork has concave joints. This joint has a groove in the middle of it. What's this joint profile called? This is called grapevine joint, which tells us we're gonna need a grapevine joiner for this process. And I'll show you what that looks like in a few minutes. I'm also looking at the color of the mortar. When it was pointed once, they used a dark mortar. They didn't quite match up the color correctly. We can do a better job at matching up the color. This color, through experience, I know that this color is antique white. That's what it's called. And I'll show you how to mix up antique white mortar. Well, what if you don't know what color to use, what color to put back in? I'll show you the process of how you can do that yourself. Now we're looking at a section of the wall that's not as banged up as the other section, and we're just trying to look at the color of the mortar. You go to your local supply place, they might have something, a kit, color kit, where you can match up the color of mortar with the color of mortar that you're trying to replace. Mortar coloring is just like paint. Tons of different colors. This particular kit is put out by Spec Mix. If the supplier doesn't have a kit similar to this, a bunch of different manufacturers make these kits. But if they don't have a kit, what you can do is you could take a chunk of mortar out of the wall and bring it to the supply place, and they might be able to match it up for you, or get real close, or point you in the right direction. Now we know the color of mortar that we're going to use, and we know the joint profile that we're going to use. What we need to know is what kind of mortar are we going to be putting back into this wall. Mortar comes in different strengths. Is this wall, we need to ask ourselves some questions. Is this wall structural? Not really, it's only holding up itself. Is this old mortar, historic mortar, or is this modern mortar? When was this wall built? If you're repairing brickwork from, let's say, 1930 and earlier, chances are it's going to have historic lime-based mortar in it. After that time, we started with the introduction of cement. This is cement-based mortar. This is pretty strong. We're going to be using cement-based mortar in this wall. That's what was used here. That's also going to tell us what type of tools we need to use to remove this modern mortar. This stuff is pretty strong. This has a high compressive strength. It's kind of brittle. It's not soft. We need to use modern tools to remove this modern type of mortar. Let's take a look at the tools that we're going to be using. This is a tool that's going to be required for this job. This is what's called an angle grinder. It's called an angle grinder simply because the head of the grinder is at a right angle to the body of the grinder. That's why it's called an angle grinder. Well, what's it do? We put different blades in here. I'll show you what the blades look like in just a minute. different types of blades for different types of situations. In particular, this is a 6-inch grinder. This one is made by DeWalt. A bunch of different companies make grinders. DeWalt, Milwaukee, Metabo, Makita, Hilti, and there's plenty of others. Another specific point about this particular grinder is this is a 6-inch grinder, and we'll get to why that's important in just a bit. This grinder also has an attachment on it. That's this big metal thing attached to it. This is a vacuum attachment. We're going to hook a vacuum up to this grinder in a little bit. The attachment also has another thing on it, and this is a depth gauge. When we're grinding out the mortar joints, when we're removing the mortar joints using the grinder, we can set the depth of the blade to how deep we want it to go. And there is a rule of thumb for how deep we should go when removing mortar joints, and we'll talk about that in a minute. This is probably the very first power tool that I recommend an apprentice, beginning bricklayer, to get. It's very versatile. We can use it for grinding mortar joints. We can use it for cutting brick, cutting block, cutting rebar, cutting tile, cutting stone. Super versatile tool. I'm going to go a little bit more in depth of what blades we're going to be using and why we're going to be using those types of blades, the types of attachments that we can put on here. Here I have an assortment of blades that we can use with this grinder. These blades are 4.5 inches. That's a 4.5 inch diameter. We're using a 6-inch grinder. Why am I going to use a 6-inch grinder with blades that are only 4.5 inches? Why do we do that? They make 4-inch grinders that will accept these blades. The grinders are smaller that will accept these blades just fine. Why buy a 6-inch grinder? 6-inch grinders are usually bought by restoration companies. They have a little bit bigger of a motor in them, a little more heavy duty, and they can cut all day. They can grind all day without having to worry about burning up the motor. We can use a 4-inch grinder and it'll work just fine. When you're grinding out mortar joints, that puts a lot of stress on the motor of the angle grinder. We would rather have a heavy dutier grinder if we're going to be running this all day continuously. 4-inch grinders do have a tendency to overheat when you're using them continuously. And when I mean continuously, I mean turning them on and not turning them off for a couple hours of just continuous grinding. That can overheat a motor. Restoration companies, masonry restoration companies, will usually invest in 6-inch grinders, but use smaller blades on the grinder. And that's what we have here. We have a 6-inch grinder. We're going to be using smaller blades. These blades, let's take a look at each one of these individually. We want to remove these mortar joints. These mortar joints are about 3/8 of an inch wide. We want to use a blade that's going to make it as efficient as possible at removing these joints. Let's take a close look at these blades. Here we have a segmented diamond blade. This is pretty thin. This is going to be used usually for cutting brick, cutting block. We can cut into concrete with this. We can cut into blacktop with this blade. This is a thin, segmented, each of these chunks are called segments. Thin, segmented diamond blade. There's diamonds in the metal here, small diamond chunks, and that's what's used to cut or to wear away a masonry surface. Diamonds are harder than pretty much any masonry we're going to be cutting. The diamonds last a long time. There's small diamond flecks in all of these blades that I'm about to show you. So this one's a thin segmented diamond blade. We can use this one to grind out the mortar joints. And what's going to happen is we're going to need to make multiple passes in order to get the thickness, the correct thickness of mortar grinded out. And that makes the job take a little bit longer. So I'm going to put this one aside. We're not going to use this one. Take a close look at this blade. This is what's called a sandwich blade. Again, diamonds, segmented diamond sandwich blade. This is basically two of the thin blades put together with a space in between. Well, now this would require less passes, less grinding, less moves, less work to do. We can make one pass with this blade in the mortar joint. It's about 3/8 of an inch thick, and this would only require one pass. There is a drawback to this blade. This blade is very fast at removing mortar joints, and that's a positive. But there is one drawback to this blade that I don't like, and it's just a preference thing. The space in the middle, obviously, doesn't get ground out. And those chunks, we're going to be attaching a vacuum to this grinder. That's what the attachment is on the grinder. We're going to be putting a vacuum hose onto this grinder. That part in the middle of the blade that doesn't get ground out, it breaks away and usually gets caught in the hose of the vacuum, and you start losing suction in the vacuum, and you have to stop and clean out the hose. Although this blade is very fast at removing the mortar joints, it makes for a little bit of a pain in the butt process when you have to continuously clean out the hose of the vacuum. This is a common type of blade that's used specifically for what we're going to be doing today. This is what's called a tuck point blade. They call it tuck point grinder blade. It's about 1/4 inch thick. Big old thick boy. Look real close, you might be able to see the diamonds in the surface of it. This will grind away the joints pretty fast. Since it is 1/4 inch thick, it doesn't have that space in the middle. This is going to make grinding, I want to say, a little more efficient. This turns the mortar into a powder, and it can be vacuumed easier. The vacuum's not going to get clogged with chunks of hardened mortar. This one, commonly found at masonry supply stores. We're not going to use this one either. We can even get a little bit better than this. Well, what's a little bit better than this? This one looks very similar to this one. This is an even thicker blade. This one is 3/8 of an inch thick. This thing is heavy. It's heavy duty also. This is going to grind the joints out real nice, a consistent width of joint. It's going to turn the mortar to powder, and it's going to be easily sucked up by the vacuum and not clog it. These are a little bit tougher to find. You might have to look online for a blade like this. This is a full 3/8 of an inch thick, and this is one of my favorite tools. One of my favorite attachments for the grinder. In this particular case, a grinder is needed for this job. We're not going to spend time trying to chisel out these mortar joints. Again, this mortar being modern mortar, this is a relatively hard mortar. If we try to chisel out the mortar joints, we're likely going to chip up the face of the brick. Not only that, it's going to take us forever trying to chisel out mortar joints. We want to grind these joints to a consistent width and a consistent depth in one pass without clogging up the vacuum. That's why we're choosing this fat 3/8 inch segmented diamond blade. Now I'm going to show you how to install the blade in the grinder. We're going to remove this nut. The blade is a fat boy blade. I need to open this up, get this in there. First, we're going to take a close look at the inside of this blade, this gold part. Keep that gold part in mind. That can be removed. There are different size, what are called arbors in grinders. They're not all the same diameter, and we can remove that gold piece to make a larger diameter on the inside of this blade. The blade goes in. I'll put the nut back on, pressing the back of the grinder. There's a button on the back here that locks as we spin the blade. Now I can tighten the nut by hand. Now I'm going to grab the blade and spin the blade. This is all we have to do to tighten the blade on here. We don't have to use the tool that came with this. This is tight enough. To remove the blade, all we're going to do is press the button and we're going to spin this off. You don't have to torque this down crazy tight. It's going to tighten itself as it's spinning. If you remember that gold ring that was on the inside of this blade, this is just the tip. This is a tip. You're going to find those gold rings laying around the job, or they're going to need to be popped out for the particular tool that you're using. You might be using a saw, might be using a grinder, mashing it up to the arbor. Keep those gold rings. This is my keychain. These are all different sized gold arbor rings. I said gold, they're not gold, they're gold in color. I've seen one of these, missing one of these, hold up $1 million job. I know it's $1 million because I was running the job. And we're replacing the saw blade. And the area on the inside of the saw blade was larger than the arbor that was on the saw, and we didn't have the correct ring to go on the inside of the blade to match up to the arbor, and it was holding everything up for about an hour and a half. So I learned my lesson. When you find these laying around, keep them handy, keep them somewhere. You don't have to keep them on your key ring, but when they're needed, it's usually an emergency. We're going to close this part, tighten it. We can adjust the depth, how deep this blade is going to go into the wall. How deep do we want it to go into the wall? There's a rule of thumb. Usually 3 times the thickness of the joint that you're removing. Well, our joint is 3/8 of an inch thick. How deep do we want to go into the wall with the grinder blade? What's 3 times 3/8 of an inch? It's 1 1/8 of an inch. We want to go at least an inch deep into the wall with this blade. Right now, it's not maxed out completely. I can get deeper with this, but I know that with this blade and with this gauge set all the way back, there's the gauge there. You can set it all the way back and tighten it. This will go into the wall 1 1/8 of an inch. As this wears down, as these diamonds wear, and this blade's gonna last a super long time. Past this job, past the next job. As this wears down, I can remove this depth gauge and get an extra 1/4 inch out of this attachment. This attachment is used for vacuum. It's also used as a depth gauge. So now we have our grinder. You can see that this little 4.5 inch blade, this grinder can accept 6-inch blades. But again, we're using a 6-inch grinder because this has a heavier duty of a motor for continuous grinding all day. I don't have to worry about burning up the motor, especially with a really hard mortar. We've got our blade attached. In a little while, I'm going to be attaching the vacuum. We're going to go over a few more tools that are nice to have for this job. This is a tool that is nice to have. This isn't a required tool to have. Definitely not in this application, this wall. This might be needed on a commercial job. This is what's called a die grinder. We had an angle grinder. This is called a die grinder. It's called a die grinder because something similar to this was used to grind dies for machining, for stamping metal. This is a die grinder with an attachment on it. They call these glitter bits. This is a 1/4 inch glitter bit. It's not glitter. Again, these are diamonds in the tip here. This spins at a very fast RPM. This big hunk of metal here is a vacuum attachment. We're going to attach a vacuum to this when we're using this. Well, what do we use a die grinder for? We have a regular angle grinder. What do we use the die grinder for? The angle iron is going to do, I want to say 99% of the work. This tool is good for that extra 1% of work. This tool is really good for head joints, and I'll show you why. This tool is really good at getting inside corners where the grinder can't get. The grinder is just too bulky. The angle grinder is just too bulky to get inside corners, sharp inside corners. This tool can come in handy. This tool will help you out. It'll save you from using small chisels. But again, we need to hook up a vacuum to this. Why do we need to hook up vacuums to these tools? Right now, in some states, maybe in this state, I'm not going to tell you where I am, it's illegal. It's against the law to cut masonry dry without a vacuum. If you're not controlling the dust in some way or making an attempt to control the dust, that's illegal. Why is that illegal? When you're cutting masonry, you're emitting what's called respirable silica into the air. Respirable, breathable particles. And those particles are harmful in your lungs. And it can do some major damage. So you, by law, are not allowed to cut dry without making an attempt to control dust. So we have a vacuum attachment on the grinder, on the angle grinder. We have a vacuum attachment on this die grinder. Only this die grinder doesn't make nearly the amount of dust that the angle grinder does. This is a tool that is nice to have. Not required, but nice to have. Here's our grapevine joiner. This is a need to have tool for this particular job. Take a close look at the profile. Looks like a slicker, a regular fat slicker, but with a nub coming off of it. That's going to give us the correct profile for these joints. In comparison, here's a regular concave joiner. This is what you're going to find probably in 99% of brick and block work. In this case, grapevine joiner, this is going to be sold at masonry supply stores. You're not going to find this at Lowe's or Depot. You can find it online, of course. But this is required. This is needed for this particular job. Now we're going to take a look at the type of vacuum we're going to be using. This is a standard shop vac. This vacuum is almost 20 years old. It's a pretty old vacuum. They make newer, better ones that would be nice to have. You need some type of vacuum. Again, this is a standard shop vac. The better ones, the ones that masonry restoration companies use, are called HEPA vacs. HEPA. That stands for High Efficiency Particulate Arrestant. That means really good, high efficiency, really good at stopping small particles. That's all that means, HEPA. High Efficiency Particulate Arrestant. This isn't a HEPA vacuum. However, we can install a HEPA filter in this vacuum, and it'll sort of work just as good as a HEPA vacuum. All a HEPA filter does is trap smaller particles. A regular filter in a vacuum is going to trap, I think it's like 95% of the dust. A HEPA filter is going to trap 99% of the dust. It just traps a little more of the dust. That's about it. A HEPA vacuum, in particular, is going to do a couple things better than this vacuum. The HEPA filter that I put in here is going to get clogged pretty quick. And when the filter gets clogged, it loses suction. We needed to maintain proper suction to remove the dust. Again, we need to control the dust. It is illegal in a bunch of states, it might be all the states, to cut dry without controlling the dust some way. HEPA vacuums, what they do is they'll clean off the filter themselves. Every once in a while, a HEPA vacuum is going to make a noise, and it's banging off the filters, getting the dust off the filters so that it can maintain suction. This is just a regular shop vac. It doesn't do that. That's one benefit to having a HEPA vacuum. I've seen other ones that are really cool where you can run an extension cord to the HEPA vacuum and then you plug the grinder into the HEPA vacuum. Well, that means you only have to run one extension cord. That's good and bad. And I'll tell you why. A vacuum requires a certain amount of energy, and a grinder requires a certain amount of energy. if they're both coming off of the same outlet, the same circuit, we'll say, it can have tendency to blow the fuse in the circuit breaker. Flip the circuit breaker. It'll blow the circuit breaker. And you have to go back and forth flipping the circuit breakers. With this particular vacuum and the particular grinder that I'm using, again, we're using a 6-inch grinder, a little more heavier duty. I have 2 separate cords plugged in, one into the vacuum, one into the grinder. And this particular wall that we're repairing is a sort of a community wall. There's a bunch of homes behind me here. I have it plugged into 2 different homes. I have the grinder running off one house, the shop vac running off another house. 2 completely different circuits, 2 completely different homes. So I know I'm not gonna trip a breaker. I'm not gonna overload anybody's electrical outlets. That's just a tip. Don't plug everything into the same outlet. Again, this is just a plain shop vac, plain vacuum. You can find these just about anywhere. Although we are going to put a HEPA filter in there. What's the HEPA filter look like? What's it look like? Here's a standard filter, shop vac filter. Here's the HEPA filter. It looks relatively the same. This one just traps more of the dust. And we want to do the best that we can in trapping the dust. I made another small modification to this vacuum. Gets sucked in here, the air gets sucked in here, and the exhaust is sort of out the back. I have a, this can be a sock. In this case, this is an arm sleeve attached to the back here. When we're geared up, what I mean geared up is when we have all of our PPE on, and I'll go over PPE, the personal protective equipment, in just a moment. I can't tell if this thing has good suction. I can't even tell if it's on when we're all geared up. This arm sleeve, and like I said, this could be a sock, whatever. As long as this is up, I know that it's sucking. If this is down, I know that it's either off or the air filter is clogged. And I gotta manually come over, open it up, remove the dust off the filter, and put it back down. Again, another benefit to a HEPA vac is we can put a bag inside of a HEPA vacuum, a regular plastic trash bag, and it'll trap all the dust in that bag. I can't put a trash bag into here. It's going to stop the suction. It's going to get sucked right to the filter, and it'll stop the suction. With a HEPA vacuum, you can put a trash bag in there, and that keeps all the dust enclosed. It doesn't let it out into the air. This one I have to dump into a trash bag. Like I said, this vacuum's 20 years old, and I'm going to ride this vacuum until it dies, and then maybe I'll invest in a proper HEPA vacuum. But until then, this is it. I forgot to talk about the end of the hose. This is the end of the shop vac hose. This attachment right here is for the die grinder. This actually screws onto the hose, and this will fit into our die grinder. But we're not using the die grinder first. We're using the regular angle grinder first. This attachment fits loosely onto the vacuum attachment for here. What we're going to do is we're going to put this attachment onto the grinder. What this does, this allows us to rotate the grinder without kinking up the hose. Well, this attachment doesn't fit onto the hose. It kind of fits into here, but not really. We got to use our universal adapter. Our universal adapter is a roll of duct tape. I'm going to tape this grinder attachment onto the die grinder attachment. Then I can attach this to the end of our grinder vacuum attachment. A lot of attachments. This is what the grinder is going to look like when it's ready to go. We have the correct blade put in there. It's set to the correct depth. We have the vacuum attachment on here, and it's plugged into a separate outlet, a separate home, a separate circuit. This is what the grinder is going to look like when it's fully ready to go. We're going to take a look at our personal protective equipment now, otherwise called PPE. Not in any order of particular importance. We're going to go over our hearing protection first. The grinder and the die grinder, the angle grinder and the die grinder, they aren't super loud, but within about 10 seconds they get real annoying. We're going to want some type of hearing protection. We have ear muffs and ear plugs. I recommend using ear muffs whenever possible. Ear muffs will usually have a higher NRR, a higher noise reduction rating than earplugs. It's measured in decibels. So you're going to see a number associated with the ear muffs and the earplugs. It's usually higher with ear muffs. Ear muffs also protect you from concussive sounds. The grinders aren't really making concussive sounds. A concussive sound is going to come from something like a jackhammer. If you're jackhammering all day and you're wearing earplugs, you can still lose hearing. The concussive sounds enter your head, around your ears, and can still make their way to your eardrums, and you can lose hearing while wearing earplugs. Concussive sounds are protected from getting into your head with earmuffs. So I recommend earmuffs whenever possible. Our eye protection. We're gonna need something. Glasses, even just a regular pair of glasses. Safety glasses, excellent. Goggles would even be better, although they are uncomfortable. In this case, I'm going to be sacrificing comfort for safety. A lot of times it's not really good to do that. In this particular case, the particles aren't going to be flying around so much. They're sort of trapped by the shroud that's around the grinder and the vacuum. Not too much stuff flying around. Goggles would be better though. We're going to need some type of breathing protection. Even though we're using a vacuum and that's sucking up a lot of the dust, most of the dust, we're going to need some type of breathing protection. We don't want to be breathing in any of this dust. This is harmful dust, which is why it's against the law to not control it when you're cutting. We've got a dust mask here and a respirator. Avoid using dust masks as much as possible in a dusty environment. These are really good at keeping dust inside the mask and not keeping stuff out. So if dust gets in here and you have this on, you're breathing the dust in and out. It's really good at keeping stuff in. It's not good at keeping stuff out. You want to use a respirator, a properly fit respirator. You can go to the store and pick one of these up. When you put it on, put your hands over the cartridges. If you can breathe in with your hands covering the cartridges, it's not properly fit. Meaning you got the wrong size or you have a lot of facial hair that the air's getting in through the mask, getting around into the mask. A properly fit respirator, super important. You don't want to be breathing this dust in. You can look into it. Over prolonged periods, you can get what's called silicosis, which is an irreversible lung disease. Once you get it, you get it. And it only progressively gets worse. Respirator, a properly fit respirator, is super important. This is the minimum PPE that we're going to be using for this particular job. Before we start grinding, I'm going to show you how we're going to be holding the grinder. This is how we're going to be holding it against the wall. The blade is going to be facing up. I want to be able to see the blade, the top of the blade, exactly where it's cutting into the mortar joint. We're going to be cutting from right to left. I'm going to be pushing or pulling the grinder from right to left. I'm going to put this part of the shroud right up against the wall. This is our depth gauge. That's going to be up against the wall as well. We're going to be cutting into the wall a little over an inch, removing that much mortar, 3/8 of an inch high. This is the way we hold the grinder. We hold it level into the wall. We're not going to angle it down or angle it up. When we're doing the head joints, we're going to use the grinder to initially do the head joints, and I'll explain that in a little while. We're going to grind our head joints out. We're going to put the shroud against the wall, and then we're going to rock it into the wall. Rock the entire grinder into the wall. It's going to be faced this way. I'm not going to face it the other way. The reason why we go right to left, it controls the dust a whole lot better than going left to right. Once we get set up, I'm going to show you what it looks like cutting with the vacuum on, and then we're going to do something illegal. We're going to cut for a few seconds with the vacuum off. Here is where we're going to do something illegal for just a few seconds. I'm going to unplug the vacuum. The vacuum's off. I'm going to turn on the grinder and grind without any vacuum attachment. Take a look at how much dust it generates in just a short amount of time. That's illegal. You can't do that. Here's a different angle of me grinding. And you can see it's not a super fast process. I'm moving slow and deliberate. I don't want to cut up into the brickwork. I'm not trying to cut the brick. I just want to remove the mortar. So you need to hold the grinder steady. What I'll do here is I'm going to unplug the vacuum, and you're going to see how much dust it creates from the side. That's how much dust is being sucked up by the vacuum. I'm sure bricklayers have some stories that they can tell of them creating dust on a side job. I've smoked out entire neighborhoods when I was an apprentice. You don't realize how much dust you're making until you turn around and you see the neighbor's window is wide open and all the dust is going into their home. Or somebody's got their clothes out on a clothesline. So any bricklayers that might have any funny stories, put it down in the comments. This view right here is actually at regular speed. This is what it looks like from my point of view. I'm looking down at the grinder blade. It looks like on video that the blade is spinning clockwise. It's really not. It's just a video. It's spinning counterclockwise. And if you look close, you can see it shooting that dust right into the shroud, into the side of the shroud that the vacuum is connected to. This is why we cut from right to left. If we were cutting from left to right and the grinder was held this way, there would be a gap on the back end where we already previously cut out, and that dust wouldn't all be collecting and going straight into the vacuum hose. If you look closely, also, you're going to see small particles flying around. This is why we wear our safety glasses. That's not really dust. That isn't the respirable silica that we're trapping. That's chunks of mortar, small chunks of mortar that are flying around. A little bigger than pieces of sand. This is why we wear eye protection. We've completed grinding out all the bed joints. Now we're going to start grinding the head joints. We're going to hold the grinder vertically. When it's on, I'm going to put the shroud, this part of the shroud, against the wall and then rock the grinder into the head joint. We can only go so deep with this grinder blade. What we don't want to do is touch the brick below or above the joint with the blade. We don't want to cut either of these bricks or leave a mark in those bricks. So we can only go so deep into these head joints. It's going to leave us with what's called a half moon shape of a cutout in the joint. That's okay, but that's not as good as we can do. We're going to use the die grinder to take out that half moon shape later on. We want to use the angle grinder as much as possible. We want this blade doing the bulk of the work. This tool doing the bulk of the work. This blade is way cheaper and lasts a whole lot longer than the glitter bits for the die grinder. So we want to use this blade, this tool, as much as possible, removing as much mortar as possible with this. What we can't get to is these head joints up here. We can get to them just barely, but we're going to hit the cast stone or perhaps the brick below. We're going to be using the die grinder a lot on these head joints, the ones that we can't reach. We're going to use the die grinder also here on this inside corner where we can't get to with this angle grinder. But we want to use this tool as much as possible and the die grinder as little as possible. Now we're going to be using the die grinder. The die grinder is going to be able to get these head joints at the very top a lot better than the angle grinder. And we're going to use the die grinder to clean up around these lower brick, around these edges, spots that the angle grinder missed. Same PPE. When we use the die grinder, we don't want to just jam this in horizontally. We want to keep this bit vertical when we're doing these head joints. We want to use the outside of the bit to be cutting, to be wearing away the mortar joint. This part of the bit is spinning a whole lot faster than the tip. So we're going to put this in sort of sideways and then angle it into the joint. Here's our vacuum attachment, and we can adjust this in and out as we go to wherever the dust is blowing. And we can spin this around. Doesn't really matter which way we use this. The die grinder looks like it's creating a lot of dust, and it is. More so than the grinder. It's actually creating less dust than the grinder, just more is escaping. We are getting still a good bit of it into the vacuum, which is another reason why we try not to use the die grinder as much. We want to use the regular angle grinder as much as possible. The die grinder is also slower than the angle grinder, which is another reason why we want to use it as minimally as possible. However, it does make for a real nice product in the end. It's getting those hard to reach places and does a great job of cleaning up around the brick. Now we're all done with grinding out the mortar joints. We use the angle grinder for most of the work, doing the bed joints and the head joints, and the die grinder for the top head joints and getting to the inside corner. We also use the die grinder to clean up the top and bottom of the half moon shape that the angle grinder left in the head joints. Well, now we're ready for fresh mortar, right? Just start pointing. Not really. We got a lot of dust in the joints, and having a lot of dust in the joints doesn't allow the fresh mortar to adhere to the existing mortar in the back and the brickwork around it. So we need to get rid of that dust. We got a few ways of doing that. We can brush it out with our brush. That's okay. We can use the vacuum and suck the dust out. That's okay, but there's an even better way. What I'm going to do is I'm going to blast this wall with water and blast the dust out. It's going to do two things. It's going to get rid of the dust, and it's going to dampen the wall. A damp wall helps us with our pointing. It helps the mortar adhere to the brick better. Damp, not soaking wet. So what I'm going to do, I'm going to start cleaning up. I'm going to get rid of the power tools. We're done with them. Start unplugging all the electrical stuff. I'm going to hook up the water hose and blast the joints out with a hose. Then I'm going to go take lunch. While this dries a little bit, when I get back, the wall's still going to be damp. And then we'll mix up and we'll start pointing. Now we're going to start mixing up mortar. I have a few tools here that are nice to have. They're not required, just nice to have. A bucket trowel being one of them. This used to be an old trowel. It still is an old trowel. But what I did was I cut the top off, and that's good for getting to the very bottom of a bucket. Instead of using your regular bricklaying trowel that comes to a point, it doesn't do so great at getting at the very bottom of the bucket. So I made a bucket trowel. If you have an old trowel laying around that you're not using, perhaps make it into a bucket trowel. It's nice to have. If you don't have a bucket trowel or an old trowel, you can use a margin trowel to mix up. We're only mixing up a small amount of mortar, not much at all. If we were mixing up a large amount, repetitively, a handheld power mixer might be something you might want to invest in. Not required, just nice to have. Now we'll start going over the mix. What mix do we need for antique white? To make antique white, what we're going to use is 1 part white masonry cement to 2 parts yellow bar sand. Yellow bar sand is available almost everywhere. Bar sand is a fine type of sand. If if you're going to buy it in bags like this, it can get pretty expensive. 1 ton of yellow bar sand delivered is like 20 bucks. 2,000 pounds of sand is like 20 bucks delivered. Or you can buy these bags, where these 50-pound bags. I think one of these bags is like 6 or 7 bucks. What you're paying for is convenience. You're also paying for consistency. I know this yellow bar sand is very consistent, meaning that it's not coming from a supply company that maybe had wood chips in the back of the truck before they put sand in the truck, and now you have wood chips in the mortar. So although this is pricier than ordering in bulk, just like anything else, it's very convenient. 1 part white masonry cement, 2 parts yellow bar sand. If you can't find white masonry cement, you might be able to find white Portland cement, and you can mix that with lime. You can use a 1-to-1 ratio, white Portland cement and lime, and then mix that with the yellow bar sand. That 1-to-1 ratio is going to give you a type N mortar in the end. This just happens to be type S mortar, which is just fine for this application. Ideally, type N would be better, but type S is just fine. I'm going to use a Wawa coffee cup. Doesn't matter what we use when we're mixing our parts, just as long as we're consistent. We can use a shovel. We can use another bucket. What I'm going to do, I'm going to put 4 cups of the yellow bar sand in here, 2 cups of the white masonry cement, before I add water, I'm going to dry mix this. It's just like cooking. I lied earlier. I didn't take lunch. I didn't stop for lunch. Working right through, and now I'm hungry. So I'm going to start relating stuff to food. It's just like cooking. We put our dry ingredients in, mix it up first before we start adding our liquid ingredients. Our liquid ingredient is simply water. We want to dry mix this until it's pretty much the same color all the way through. And now we can start adding water. What's the consistency we're looking for this step of the process? I'll tell you what we don't want. We don't want mortar on the wet side. It would go in a whole lot faster if it was on the wetter side. It would be a whole lot easier to work with if it was on the wetter side. But it's going to probably be a little sloppy. What we're trying to do is get it in nice and neat, and ideally we won't have to come back and wash this down. This step of the process is pretty important. We want to make the mortar almost as stiff as possible, but workable. Mixed to a decent consistency right now. going to let it sit for about 2 minutes. Whenever we mix up a mortar or a thin set for tile, if we're mixing up a small amount, something like this, we're going to let it sit for a couple minutes. That's called slaking. We are slaking the mortar. We're letting all of the masonry cement and all the sand absorb as much water as possible right now. We're going to let it sit, and then we're going to remix it. If we're mixing up a big batch, we would just let this mix in the mixer, or we mix it with the powered hand mixer, and it would pretty much be good to go. Right now, this is like a medium consistency. Maybe on the harder side. I wouldn't want to lay brick or block with this mortar. It's on the stiffer side right now. I'm going to let it sit for a couple minutes. And then I'm going to mix it up again, add water if needed, and then we'll get to pointing. Now we're pretty much ready to start pointing. Start filling in the joints with fresh mortar. There's a few need to have items. You're going to need slickers. Slickers come in different sizes. This is what we're going to use to pack the mortar into the joints. Ideally, you'd have a set of slickers. Like I said, they're different sizes, from skinny to fat. For this application, we're going to use like the medium one. Medium to fat, I'll say, for most of this process. Then, after we pack it in with our slicker, we're going to use our grapevine joiner. Another need to have item for this particular job. Off camera, the mortar didn't get as stiff as I wanted it to, so I had to add a little more sand and a little more masonry cement. But we want the mortar relatively stiff. The reason being is this wall is still damp. We want to do this process while the wall is damp, not soaking wet. What we do in this part of the process affects the next step. What we don't want to have to do is wash this wall down. We can make the mortar wetter and it'll be nice and easy to work with. We can even use another cooking term, a piping bag, and we can fill up the bag just like decorating a cake, the way they decorate cakes, and we can squirt the mortar into the joint. The mortar needs to be relatively wet. There's even motorized machines that do that. You fill a hopper in with relatively wet mortar and it just pumps it into the joint. It makes this part of the process really fast, but it usually adds one more step to the process, and that's wash down, where you have to come back to the job and wash the wall down with some type of detergent, some type of acid to clean the wall up. Well, if we can avoid that step, it makes the overall process quicker. It might make this part of the process a little slower. A nice to have item would be a hawk. We can load this up with mortar, and what I'm going to do, show you an easy way to point. We're going to load this up with mortar, and we're going to hold this right up against the wall, and we're just going to scoop the mortar right off of the hawk into the joint. Sometimes, usually when doing commercial work, there's going to be pointing requirements, and they won't allow you to just shove a bunch of mortar into the joint at one time. You'll have to point the brick in what are called lifts of mortar, L-I-F-T-S. Usually a lift of mortar is 1/4 inch at a time. We have about 1 inch of depth in this joint. We would need to do a 1/4 inch of mortar, then a 1/4 inch of mortar, 1/4 inch of mortar, then another 1/4 inch of mortar. They want to see 4 lifts of mortar. What that does is help avoid any voids in the wall behind the mortar. again, where water can get to and start to deteriorate the mortar. Sometimes it's going to be required to point the wall in lifts. In this situation, not really. I'm going to load up the Hawk and show you some of the process. As a right-handed mason, you usually want to start from the right side of the wall and you work your way left, going back over the part that you just filled in. You're packing it in more. Right here at the inside corner, I can't really get the slicker in there. So I'm going to do this part left-handed for a little bit until I can get to right-handed. The wall is damp. I should have wet this Hawk before I put mortar on here. That helps the mortar actually stick to the Hawk a little bit better. I'm going to hold the Hawk right up against the wall. I'm going to shove that mortar in the joint. Now I'm going to work my way to the right. Working my way to the right. I only have about a 1/4 inch of mortar packed into that joint. I'm going to do that again, starting over on this left side. I'll do it one more time, packing it sort of all the way out to the face. Now, as a right-handed mason, I can go way quicker, working my way right to left. We just want to get this mortar in the wall. And that's packed in there fairly well. Now I'm going to do the head joints right above this bed joint that we just did. These are a little more difficult if you're just starting out. You're not able to hold the Hawk up against the wall. We need to remove the mortar from the Hawk with the slicker. Packing it in. I'm pressing that mortar into the joints. Now we're going to go to the joint above. Start the same thing. I'm going to work a little bit from left to right. Switching up the size of the slicker so I can press this mortar in all the way to the back of that joint. If you don't have multiple sized slickers, you can simply hold a fatter slicker at an angle and press this in, press the mortar in. I'm going to do that again with the thin slicker. Load up some more mortar. And now I can go right to left. There needs to be something to the right, if you're a right-handed mason, for the mortar to come off of the slicker. This mortar wasn't here. Dig this out. And I go to put this in the wall, there's nothing, it wants to stay on the slicker. If I have something to work up against, it's always going to come off of the slicker. And I'm packing over the part that we previously did. Now I'll move up. Now we'll go to the top joint. We'll work our way to the right at first. And now I can start working right to left, packing this mortar in, without this wall being in the way of my hand. Mortar out to the face, getting it ready for the next part of the process. We'll do these top joints. Good. Mortar's packed out, but doesn't look that great. We need to go over it with our grapevine joiner. This is going to put that groove into the joint. Usually we'll do head joints first and then the bed joints. That's what was done previously on this wall. So that's what we're going to do now. I'm going to press and form that joint. Now we're going to do our bed joints. The joint doesn't need to be perfectly straight and level. Try to hold your hand as steady as possible when doing this type of joint, but it doesn't need to be perfect. This is supposed to resemble a vine, I guess, growing up a wall or something like that. This still isn't 100% what we're going for. We have all this ooze coming out around the edges. I'm going to let this mortar set up and then we're going to cut it off. We might brush the wall and then polish it. Now we're back at the beginning. All I'm going to do is cut the excess mortar off, brush it lightly with a brush, and then go over it with the grapevine joiner to polish it. that pretty much wraps up pointing a brick wall. Pointing is a lot like pizza. For the most part, there's only two parts to pointing a wall: removing the mortar and putting fresh mortar back in. Well, pizza's only got crust and sauce and cheese. You can get a slice of white bread and put ketchup on it and like shaker cheese on it and stick it in the microwave and say that's pizza. I guess it is. I mean, you've probably had good pizza and bad pizza. There's only three things to do with it: dough, cheese, and sauce, and how you cook it. But each one of those little things matters in the end product. How wide you grind out, how deep you grind out. Are you going to leave those half moon shapes in the head joints? Are you going to leave dust in the joints? What's your mortar mix going to be? Is it going to be the right consistency? Is it going to be the right color? Is your mortar joint going to be the right shape? There's a whole bunch of things that go into pointing. It's not simply just removing the mortar and putting fresh mortar in. The more time you take, the more effort you put into the work, the better end result you're going to have. Right now, this mortar doesn't quite match. It's only about 10 minutes old. Give it about a week, it'll start looking like the rest of the wall. Give it a month and it'll blend right in. What you do in each step of the process determines how easy the next step of the process is. Pointing brickwork can be very lucrative. You don't need many tools in order to do this. There's entire companies that are built around pointing masonry. You can get started simply with a grinder. Invest in a decent grinder and go from there. It doesn't take many tools in order to point brickwork. It doesn't take many different things to make pizza. That's enough. I'm going to get something to eat. That's pointing brickwork. I hope you enjoyed the video.
Oh yeah. Oh yeah. Any pizza could be a personal pizza if you just believe in yourself